So one of the advantages of FM compared to AM is that FM is not noisy, where AM is noisy. What do you mean by noisy? That means you hear the static at the background. For FM, when you hear FM radio, it sounds like a CD quality, right? You practically like hear the music and the sound clearly. There's no like something like shh like that. Don't have, right? That is if you want to pee lah. But if for the rest of y'all, you won't hear that, right? But for AM, you will hear always at the background like shh, a lot of these static sounds. So why is AM noisy but FM is not noisy? The reason is because in amplitude modulation, the amplitude is the one that is changed. So because your amplitude is changed, it will give you noise at the end. I'll show you. Now let's say I draw a radio, and your radio is receiving this signal, amplitude modulated wave. Now, all around us there is noise, and when the noise we're talking about is not the sound type of noise, but noise in the form of EM radiation. Now, why is there noise in the form of EM radiation? That means you got stray signals with no meaning one. When do you get this stray EM radiation? Whenever there's a charge accelerating or decelerating. Somebody starting the car, turn on the light switch, turn off a light switch, all these will cause current to either accelerate or decelerate charges, accelerate and decelerate, and that generates EM radiation. And you'll be surprised that actually there's so many frequencies of this noise out there, because so many things can generate noise, and most of them have different frequencies. So at the frequency that you are tuning into, you will also have noise at this frequency one, for sure. Whatever frequency you tune to will have a noise at that frequency also. You cannot escape from noise one. Which is why noise, by definition, is called unwanted power that covers the whole spectrum. What it means is, at any frequency that we are using, also got noise one. Understand? So what will happen when you have noise? So let's say at this particular frequency, you have noise, but it will be relatively small like this, at this frequency. When this one also goes into your aerial, because your aerial is set, or rather your radio is set to tune to this frequency, so it will also receive this frequency of noise. So what will happen is, both of these signals, they will interfere. So through superposition, both waves will add together and will give you a resultant wave that looks like this. That means your original radio wave will have now peaks due to the addition of this noise. So when your radio is trying to interpret this signal to produce an information, remember big amplitude means positive displacement. Small amplitude means negative displacement. But the problem is, you also have all these peaks here, which the radio will not know whether it is information or noise. It just interprets the amplitude and produces an information. So your resultant displacement will also have all these peaks here. All these peaks appearing. Which is why, when this signal goes into your speaker, it causes your static sound. So it's noisy. What about FM? When FM enters your radio here, at this frequency, also got noise, guaranteed one, got noise one at that frequency, because noise exists at any frequency one. But when we add up this noise to your frequency modulated wave, by superposition, it also affects the amplitude. Agree or not? Okay, it will give you all these peaks. But when the radio is trying to interpret this signal to produce the information, what does it look at? Does it look like amplitude or does it look at frequency? Frequency. High frequency, positive displacement. Low frequency, negative displacement. So since it does not even look at all this amplitude, when they produce back the information signal, it will just produce a nice, clean wave with no noise. You see, noise will only affect the amplitude, because if these two have the same frequency and they add up, it will just affect the amplitude. If these two have the same frequency, so add up, just affect the amplitude. Correct or not? But since in FM we don't have to look at amplitude to get information, we only look at frequency to get information, so it's unaffected. So that is your first advantage of FM. Less noise. Understand? The second advantage of FM over AM, if you ever hear the radio, is that FM, the music and the sounds richer. But AM, the music or the sound sounds muffled. Alright, if you ever heard before. So what I mean by muffled, right? Like right now you can hear my voice very clear, very sharp, right? So muffled, if it's like I close my mouth now, and then when I talk, everything sounds muffled, right? Can you hear the higher frequency or not? You cannot hear the higher frequency, right? It sounds like everything is very dull. Okay, so now it's very clear, right? Now you can hear the full richness of my voice, right? So AM, you will hear a very rich music and sound, but AM, everything is like muffled. Why? Because AM will have smaller bandwidth and FM will have higher bandwidth. Smaller bandwidth means you can only fit in a smaller audio frequency. So the higher frequency will be cut off. But FM has higher bandwidth, so you can fit in even the higher frequency sounds or music, so you'll hear a richer music. Let me give you an example. Now, these three are long wave, medium wave, and short wave. Do you realize that operate at the lowest frequency regions of this radio spectrum? These frequencies are used for radio or TV or satellites. All these are wireless communication. So the lowest frequency that we can use is 30 kilohertz. So 30 to 300 long wave, 300 to 3 megahertz medium wave, 3 megahertz to 30 megahertz short wave. All these are the three lowest frequency range, right? When the frequency range is small, your bandwidth is also small. Example. If I look at long wave, between 30 kilohertz and 300 kilohertz, how many frequencies are available between 30 kilohertz and 300 kilohertz? So a number of frequencies available will be 300 kilohertz minus 30 kilohertz, and you will get 270 kilohertz of frequencies available. So when I give a particular radio station a bandwidth, that means I'm going to give them a section of these frequencies I am allowed. That means, okay, within these frequencies 270, each station I give 9 kilohertz, for example. So I say, okay, each station is allowed 9 kilohertz bandwidth. So if you divide, so you end up with only 30 stations operating, right now. But when your bandwidth is only 9 kilohertz, you will realize that what is the highest frequency or audio frequency you can give to each radio station? What is the highest frequency of the audio that you can fit in? Remember, for AM, if we draw a frequency spectrum graph, you have three lines, which is FC, FC plus FA, and FC minus FA, right now. When I say the bandwidth given to each station is 9 kilohertz, it means it's a range from here to here, right now. So what is the highest audio you can fit in? You can only manage to fit in an audio of 4.5 kilohertz. Because the bandwidth is always 2 times FA, or it will be this minus this. So if FC plus 4.5 minus FC minus 4.5, you will get 9 kilohertz. So it's not like you can choose, say, oh, I don't want 4.5 kilohertz audio frequency. That's not enough, I want 10. Cannot. Because each station is limited to 9 kilohertz, so you are forced to use up to maximum 4.5 kilohertz audio. So any sound or any music more than 4.5 kilohertz frequency will be cut off. That's why you don't hear the higher frequency notes or the higher frequency sounds. That's why you hear everything that's muffled. Now, if you say it is not enough, because actually what is the maximum frequency for humans to hear? 20 kilohertz, right? Not? Ideally, we will need to transmit an audio of 20 kilohertz. So be 20 kilohertz, FC plus 20, FC minus 20. So what should be the bandwidth? 40 kilohertz. But if I give each station 40 kilohertz, how many stations can operate? I have 270 kilohertz available. Each station I give 40. How many stations can operate? Only 6, which is not enough. Because if let's say there are many stations that want to operate on this waveband, I cannot give each station so many bandwidth. I must give it less bandwidth. Then more stations can share. If I give each one 9, then 30 stations can share. If I give each station 40, only 6 stations can share. Do you understand? So because of your limitation that you cannot give up to 20 kilohertz audio, you only give the 4.5 kilohertz, that's why it sounds bad. But what about FM? Now what about FM? Now why does FM sound so much better? Because FM operates at the way higher frequency region, which is 30 megahertz to 300 megahertz. If it is between 30 megahertz to 300 megahertz, that means you got altogether 270 megahertz frequencies available. How do I get this? I take 300 minus 30. Got 270 megahertz of frequencies to share. And you know what? I give each station a bandwidth of 200 kilohertz. And I will still end up with 1,350 stations that can still operate. You compare with your long wave just now, when you only had 270 kilohertz frequency to share, so each one you only gave 9 kilohertz, and you end up with 30 stations, right? You compare with our FM, we give a bandwidth of 200 kilohertz, when for a long wave we only gave it 9 kilohertz. So if you are going to give FM 200 kilohertz, that means it can fit in the entire audible frequency range from 20, right up to 20 kilohertz. But some people ask me, why 200 kilohertz? Because if your FC plus 20 and FC minus 20, your bandwidth is only 2 times 20, which is 40 kilohertz, right? So why do I give it 200 when they only need 40? Now you must understand, if it is AM, you will only have 3 hidden waves. But when you're doing FM, you will have infinite number of sidebands. That means it's not like you purposely want to generate all these hidden waves. It's just that when you do frequency modulation, the wave that is produced will automatically contain an infinite number of hidden waves. What are these sidebands? You have FC, FC plus FA, FC plus 2FA, FC plus 3FA, FC plus 4FA, and so on and so forth. The other side will be FC minus FA, FC minus 2FA, FC minus 3FA, and so on and so forth. But the good thing is, as you go further away, these sidebands will start to taper off in amplitude. The amplitude will get smaller and smaller. So we just have to give it sufficient bandwidth to cover the bigger amplitude sidebands. The smaller amplitude sidebands, negligible. But why must we give it this bandwidth to cover all these multiple sidebands? If you don't do that, there will be interference when you let another station operate and overlap these frequencies. Because these waves will still be there. So another station operates too near to this frequency, to this carrier frequency, then its multiple sidebands will overlap with these multiple sidebands. So when you receive it, when you tune to that frequency, you automatically get a bit of the other wave. So you got to give it more bandwidth to allow for these sidebands to become negligible, which is why you give it 200 kilohertz. Understand that? You can afford it because you have 270 megahertz available. So even if I give 200 kilos, I still got 1,350 stations that can share that FM bandwidth. Understand that? So because of that, FM sounds so much better. Do you understand that? Now, the next thing I'll tell you is this. Now, what about people say, can I use FM at this range or not, the long wave? Now, theoretically, you could. Because FM and AM is up to you. But if you use FM and you give it 200 kilohertz, remember you only got 270 kilohertz bandwidth, the available frequencies to share. But you give one station 200 kilohertz, only one station can operate. That is why for lower frequencies, when you have limited bandwidth, you tell the stations to use AM, because you would avoid the problem of multiple sidebands. But higher frequencies, can you use AM? Can, but it's just wasteful because there's so many frequencies available. You use AM to save on your bandwidth, but you don't have to because you got so many frequencies available. So higher frequencies can use FM. So we use FM. Lower frequencies, not enough frequencies, so I don't use FM, I use AM. So therefore, second advantage of FM is, it is much better quality. Okay? So what is the disadvantage of FM then? Now, the disadvantage is that FM needs many transmitters to cover the entire country, but AM only needs one or two or very few transmitters to cover the entire country. Why? Because FM will only travel very short distances, so you need many transmitters. But AM, which is actually using the lower frequency waves, can travel further. So why do they travel further? Now the behavior of the waves actually depend on their frequencies. Alright, so since your AM, which is long wave, medium wave, they have this frequency of less than 3 megahertz, they actually behave like surface waves, as you can see here, surface waves. So these are surface waves, the first one. Let me just move down a bit. Okay, these are surface waves. And surface waves can actually bend according to the Earth's magnetic field. So that means you can actually send the wave a bit higher, and then because of the magnetic field, it will actually travel a bit further when it actually curves down. So because of this wave have about the range of 1,000 kilometers. So imagine if you put this long wave or medium wave, because long wave and medium wave both are below 3 megahertz. If you put a transmitter right in the middle of Malaysia, for example, you would theoretically you could just cover the entire country, just one single transmitter. But then the short wave, which is another AM, is a sky wave. So for sky waves, they actually behave differently. This one you can actually send up to the sky, where they will reflect off the layer of ionosphere, and then it will bounce back to the Earth, and then it will bounce back to ionosphere, then bounce back to the Earth. So that way, it could go worldwide with a single transmitter. So long wave and medium wave, sky waves, which is actually short wave. Short wave radio is between 3 megahertz and 30 megahertz. They have a much further range than your FM, because FM has a frequency more than 30 megahertz, so they travel like space waves. For space waves, they can only travel line of sight, and if they can only travel line of sight, we will need multiple transmitters to cover the entire country. Now this is another example why you need, when you're traveling, let's say from Selangor to Penang, right? Do you realize that you keep having to keep on having to adjust your radio so that you can you need to tune to a new frequency to maintain the same station? So why that happens is because of the range up. Now imagine that you have another transmitter here, and it has a range like this. Now the part of its coverage must overlap with the next transmitters coverage. Now why must they overlap over at this point? Because if the car is moving across from one state to another state, when it reaches this area, but your coverage is only right up to the boundary, but the car reaches that boundary, then there'll be no coverage at all. So maintain coverage in the whole country, you have to overlap. But when you overlap and you don't use a different frequency, that means you're using the same frequency here and here, when the car is at this point, it's tuned to this frequency and this frequency is the same, so it receives both at the same time. And if it receives both at the same time, there will be interference at your area there. So because it receives both the signals which have same frequency, so there will be interference and it will be coming from different distances. So there will be a path difference which will cause a phase difference. So you may end up having constructive or destructive or alternating constructive and destructive. So therefore you cannot have that. So therefore you use a different frequency here and here, so that when you are tuning into this frequency and you reach the boundary here, you will notice as the signal gets a bit soft, that means you're probably reaching the end of the coverage, then you can switch over to this frequency, which is the next transmitter. But there will be a region right in the middle here where you notice that either one also quite clear. Right now, it's because you're right in the middle, but as you leave the coverage of the first transmitter, you get very weak. That's when you can switch over to the second transmitter, which operates at a different frequency to avoid interference. Alright, so that is the weakness of FM lah. So FM, first weakness, needs more transmitters. So more transmitters means end up having to build more transmitters, means cost is higher lah. And also another disadvantage of FM is that the FM circuitry, that means the circuit to generate FM, is actually more expensive than AM. So overall your cost is higher lah. But when you're talking about countries which are developed or developing, if they got money, they will always switch to FM because of better quality. But if let's say the country is poor, or they don't have funds to actually go to cover the interiors or some place which are remote places, then they can use AM because it can reach further, even though their transmitter is far away. So usually what they used it for was last time, if you want to like spread propaganda, like political propaganda or whatever, so you can actually just use AM because you don't need much money and can cover very far. Okay?